So here we go. So now it's been probably been about 5 minutes. But now, as you can see, we went from clear, and even if okay, let me show you a little bit of the reaction going on here. So now we have a yellow color that's happened. Okay. Now I want you to know right away that when you see the yellow color, that's usually iodine. Okay, so it's not always iodine that's a yellow color, but in most chemical reactions, iodine stands out as yellow. Sulfur is usually yellow, but it's a different yellow. This particular color that we see right away, as a chemist, we're thinking, yeah, it's an iodine, what we call iodine tincture, meaning that there's a high concentration of iodine. So a while ago when I showed you the bubbles in there, okay, I want to turn this up, okay. So now when we look, okay, we don't see any bubbles. So even when we crank it up high, okay, remember a while ago how we had bubbles on the top? That's because the oxygen was being given off. Now all of the oxygen is being absorbed, okay? All the oxygen is being absorbed. Now let's come back over here to our chemical equation. So now it's kind of interesting because, see, look what we have, okay? And I wanted to show you this earlier because now where did the oxygen go? When I saw the bubbles, there was hydrogen bubbles being formed, okay? And then we had another set of bubbles that was oxygen. Well, where are they at? They're attached to the iodine. Oh, that's interesting. So here's what we have. So hydrogen peroxide dismantles into hydrogen and oxygen. Now, it's kind of cool. So in this side of the reaction, okay, and this is what we're trying to learn as chemists. We're trying to say, okay, matter cannot be created or destroyed, it only changes forms. So all of these chemical elements stayed the same, except that they combine different. So here's the first half of the equation. You see what we've got here, okay? So now this is what's being formed now. So now we have the iodine, okay? Now we have the iodine that is absorbed. Now we have the iodine that has absorbed the oxygen. Oh, cool. And it's giving off the H+. Now, in the second part of the reaction, which we'll be able to see, which I see it's beginning to change now, okay? And we'll look at it here in a minute. But now we're going to form the second part of the reaction, okay? Which is going to be this strong starch solution with 2 oxygen molecules and 3 water molecules, okay? So now if we'll come back over and look at our container here, now we've got a whole different color, okay? Now, I don't know if you can tell, but that's actually a dark, kind of a bluish green color. Now, that's the color that we associate starch with, okay? So a starch solution generally has that color all the time. Now, remember iodine? It was yellow, kind of a dark yellow color, slightly brownish yellow. But look at this. This isn't a bright blue, okay? It's kind of a greenish blue. And now that is in the equation. That's the starch. So see, when we had this equation earlier, the iodine was the dominant structure. We went through this, and it was giving off hydrogen. Oh, that's kind of cool. But now what we have, now this one has come back to the starch solution is the main thing we see, and it's giving off 2 oxygens and 3 waters. So when we look at this, now let's see if we see any bubbles being given off, okay? We crank this up, and once again, look, I've got it cranking full, and we don't see any bubbles being given off at all. Now, if this was just water or any other solution, okay, if this was just water or any other solution, we would see bubbles everywhere because hydrogen peroxide would be giving off the oxygen. But what's happened is it's all absorbed into the equation. It's all absorbed into the equation. So it's kind of cool. So what you saw was you saw a chemical equation. You saw us go from this step to this step. Now, it's kind of interesting because it will take it, and we won't be able to have enough time to run it in the lab, okay? But within 10 or 15 minutes, okay, of this thing running, then what do you suppose it'll do? Well, it's a chemical equilibrium. So that means that this will mix for a while, And then all of these ingredients will go back to the step 1, and this will turn yellow again, okay? And then after 10 or 15 minutes, it'll turn blue again, and it'll go yellow, blue, every 10 or 15 minutes until what? Until the hydrogen peroxide has lost just enough oxygen into the atmosphere that it no longer can account for all of the elements in the equation. So let's go back and let's talk about 2 or 3 things that we've learned in this lesson, okay? We've learned, first of all, that this is chemical equilibrium. It means a reaction can go one way and then it reverses itself, also known as a reversible reaction, and goes back to the other side. We've also learned that matter can't be created or destroyed. Everything has to be accounted for, okay? So that means that in this reaction, all of the elements are the same on this side of the reaction as this side, but they've combined in a different way. We've also learned that hydrogen peroxide is H2O2, and that hydrogen peroxide is the catalyst for this reaction, which speeds it up and slows it down. So basically what we have in the early one, okay, hydrogen peroxide was the reaction that caused it to go here, okay? So now what's going to happen is, in this part of the reaction, where we go from the blue to the yellow, what do you suppose this 2O2 plus 3H2O, what do you think in this part of the reaction that's going to form? Well, think about it for a second. See, and you're beginning to see the idea of a reversible reaction. These two are going to make H2O2. They're going to make hydrogen peroxide and start this reaction all over again, and the iodine will separate out. The iodine will separate out, and we'll balance our equation out, and then the H2O2 will go back. And so it's called a reversible reaction, a reaction in chemical equilibrium. We learned that the brownish yellow color is iodine, and the blue is starch. So once again, we're going to come back and talk about chemical equilibrium a little bit later, but I wanted you to see it in the lab. This looks like kind of a mess, and it looks kind of crazy, but the thing I want you to know, you're not going to have to memorize the equation. What I want you to know is that we have a catalyst, and in this case it's hydrogen peroxide, but we need to know that once it's broken down, then it's remade in the other part of the reaction, and that's what causes the chemical equilibrium to work. Now, is there any hydrogen or oxygen in the atmosphere that's contributing to this reaction? And the answer is no. Everything we need is here. But when will the reaction stop? When we lose oxygen or hydrogen, and we lose those to the atmosphere, okay? So eventually, so this won't run forever so the original reaction is the dark yellow, and the second part of the reaction is blue. So it goes yellow, blue, yellow, blue, yellow, blue, until we lose some of the oxygen or hydrogen to the atmosphere so that we can't make the new hydrogen peroxide. Once again, looks pretty complicated. Let's take one last look at this. We can see that it's getting just a little bit thinner color. As a matter of fact, we won't run this too long, but if we'll look and we'll see that we're beginning to get, if we'll shine that right on the top, we'll see that it's beginning to get thinner, and we're starting to get a little bit of yellow form. There we go, starting to get a little bit of yellow start forming. So once again, chemical equilibrium, and we'll have a few questions on this. We'll have a few questions from this lab on your next quiz, on your next lab quiz. But once again, chemical equilibrium.